Assalamualaikum. My name is Muhammad Razin Akmal bin Azman. My ID number is MA22138. So, firstly, this is a video of how does the gate moves when the gate is closed and open. Next, we go to the dimension of outer gate, the double side of outer gate. So the top of the picture, we can see that the half of the outer gate is 2.47 meter. So for the one side at half outer gate is 1.37 meter. So the bottom of the picture for the A to B 1.37 meter, and the same measurement for B to O is 1.37 meter, and the angle for the O is 30 degrees. Next, for the velocity of midpoint of panel AB when theta is 30 degrees where the gate is open, we're using the three methods, which is vector, IC, and MATLAB program.
I'll be explaining the vector method for this assignment. First, we begin by listing out the known parameters. We have length of OB, length of BA, length of BC. C is the predetermined midpoint which we are trying to find for this assignment. And then we have value of theta, value of velocity at point A, and then we also predetermine that clockwise is positive direction for this assignment. Now we start off with our calculation. We first want to find the velocity at point O, which is 0 because point O is fixed. Then we move on to velocity at point B, where we use the standard formula VB equals to VO plus VBOO. We plug in our values. Since this is vector method, we are going to get an answer in terms of I and J components. Now we find the velocity at point B once again, but this time in respect to the other bar. Before this, we did bar of OB, now we're going to do bar of BA. So we use the same formula, VB equals to VA plus VBOA, and then we'll once again get another answer in terms of I and J components. Now as you can see, we have two equations for velocity at point B. So we're going to equate both of the equations, then we're going to break them apart into their I components and J components. Once we've done that, we can now use simultaneous equation method to be able to find the value of omega BA. And as you can see, based on our calculation, we were able to get 0.11 radians per second. So with this information, we can now move on to finding the velocity at point C, where we use the same formula, VC equals to VA plus VCOA, and then we plug in our values and we're able to get the answers in I and J components. But we want to find the magnitude of the velocity. So what we do, we'll square our I component, we square our J component answer, then we'll add both of these answers together and square root the total of both I and J components. And therefore we end up with a final answer of 0.13 meters per second. That is all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Muhammad Zafran bin Wan Zailani. My metric ID is MA22146. Today I will present to you about IC method. First and foremost, to find the point of IC, we have to find the direction of the velocity of VA and VB, because from the direction of VA and VB, we can make a line that is 90 degrees from the direction to find the point of IC. And then after we find the IC, we can find, based on the information given, we can find the angle of the triangle, which is 60, because the triangle is have a same dimension. And then from that we can find WAB, which is 0.11 rad per second, and then we use a cosine rule to find RAIC and RBIC, and then after we find that, we get the point, we get it, and then after that we make a new IC to find the midpoint of a midpoint from point A and B, which is we make it to point C. To find this midpoint, we use formula of C square equal to A square plus B square minus 2AB cos theta. And then after that, we can find the answer for C, which is 1.19 meter. And then from that answer, we can find the velocity of midpoint by calculate WAB multiply by RCIC, which is 1.19 meter. And after that, we can get the midpoint of AB, which is 0.13 meter per second.
Assalamualaikum. My name Muhammad Farid Haikal bin Muhammad Rosli. My student ID is MA22135. So now I will continue for the MATLAB program. So here we can see our coding starting from the given data. So we have the given data and just paste it at the coding. For the length of AB is 2.74 meters, and the theta opening for the gate is 30 degrees, and the average we got for the velocity A is 0.15 millimeter per second. And then we calculate and plot the angular velocity of panel AB and OB against theta. So that is the title for our programming. And then next for the theta values, our coding we write as a line space 0, theta open 100. And for the angular velocity AB, the coding we use average underscore velocity underscore A. And for the angular velocity OB, we use coding average underscore velocity underscore A. So this coding we want to figure it out, the angular velocity and the degrees for panel AB and OB. So next we use the coding line width. So the as we can see at our coding, we write it plot theta value and angular velocity AB. And we also can see at the bottom we write the coding about the title, X label, Y label. X label is for the X axis and Y label is for the Y axis. And then we run our coding and we got this graph. So we can see all that we write at the MATLAB will run, and we got this graph. So for the graph title, yes, same angular velocity of panel AB and OB, and at the x-axis we have angular velocity in radian per second, and at the y-axis, at the angular x-axis we got degrees, and at the y-axis we got angular velocity, which is in rad per second. So this is our coding for MATLAB. Thank you.